Today we talk about polygons. You may think that you know what a polygon is, but it's very, very specific. Okay? Very, very specific. So first we need to learn what a little thing that's not a polygon called, just a plain old figure. A figure in geometry is just any set of points. Set of points is a figure. Give you some sort of points, that is a figure. Everything you see in these charts are figures. It's some sort of points. These over here are polygons. These over here are not polygons, and we'll learn why. But there's a figure right there. Correct? It's a set of points. Newt, 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 newt. There's a figure right there. It's a set of points. Right? Anything that you can think of is a figure. Right? Set of points. A polygon, however, is this. Very tricky definition. It is a closed plane figure made up of segments such that each segment intersects exactly two other segments at their endpoints. So you can pause the video and write that down, and then we'll talk about it. It's easier to talk about things that are not polygons first, and then realize why all those other things over there are polygons. Again, we said that it's got to be a plane figure, meaning it's two-dimensional whatsoever. Closed, however, though, is part of it, meaning you can't have anything that's open. Do you see this guy right here? How, like, if you start here and trace around, you've got this spot where they don't end up connecting to each other. That's not closed whatsoever. That is open. So that's why this is not a polygon, because it is not closed. You cool with that idea? Made up of segments. What do you think about this guy? Is that a polygon? Obviously it's not. But why not? Segments are straight, and this is a curve. This is only made up of nothing but points right here for it to come around. That's an ellipse. Even if you had a circle is not a polygon because it's not made up of segments. Are you with me on that? So it's got to be made up of segments. Then each segment's got to intersect exactly two others. So watch my highlighter, if I can get to it and not use blue. See this segment right here in this situation that I've highlighted red? Let's see how many places it touches. 1, doesn't it touch another segment right there? 2, doesn't it touch another segment right there? And 3, too many times. It's got crisscross, right? It can't happen. Each segment can only intersect exactly two other segments, correct? And where are they supposed to intersect at? At their endpoints. So if I highlight this guy, how many places does it touch another guy at? 1, 2. But where does it touch it at? Not at the end point of it, right? Excuse me, there's overhang in that guy right there. You with me? So why is this guy not a polygon? Could you tell me, out of all of those rules, why is that guy not a polygon? It's got a curve, right? So that's in our own words. Now, according to the definition, which thing got highlighted up in the definition? Not made up of segments. What about this guy right here? Not made up of segments. What about this guy right here? Why is that not a polygon? Doesn't intersect at endpoints. In our own words, it's got overhang, right? You know, it overhangs too much. Why is this guy not a polygon, if my pen would work? Why is that not a polygon? It's got overhang and intersects in more than two places, correct? So very, very specific. If you look at all of these guys, you can see that they are polygons because they fit all of those definitions, okay? Why is that not a polygon? It's three-dimensional, right? Not two-dimensional, so it's not a plane figure. Next guy, parts of polygons. Hey, that test that I handed back to you from Chapter 1, worst thing about it was front page, bottom question. Name the sides of this angle, correct? Name the sides of this angle. They had to be raised. Some of you had no idea how to answer that question. Time to get specific. Parts of the polygons. The sides of a polygon. Can you tell me what they look like to you? What are the sides? They are segments. Boom. They are the segments that make up the polygon. Not lines, not raised, segments that make up the polygon. The segments that make up the polygon. And we'll do an example later where we'll name all this stuff. Cool? They are the segments that make up the polygon. So for example, you got segment GH, segment HJ, segment JK, and etc. All of those bad boys, right? Vertices, that's a weird word in its own, the vertices, right? The vertices are this, the endpoints of the sides of the polygon. The endpoints of the sides of the polygon. The endpoints of the sides of the polygon. Name me a side of this polygon real quick. Name me a side. Segment GM is the first one I heard. You know, there's one of them, right? What are the endpoints of that side? G and M. So isn't G a vertice then? And isn't M a vertice, right? Name me another vertice. J is a vertice. Name me another vertice. K, L, M, G, J. The letters are the vertices. These points, the cornery type of points, if you will, those are the vertices. You with me on that? How would you write it down? If I asked you to name this for me, what would you write down? Capital H. It's a point, right? A point. Consecutive sides. What does consecutive mean to you? Right in a row. Like if I won consecutive national championships, didn't I win them right in a row? 2000, 2001. Consecutive years, right? So consecutive sides are sides that are right in a row. Meaning, if you go around the clock, let me get a highlighter here. Here's a side right here. If I go around the clock, isn't this, right? The next one, right next to it, correct? That's if I went clockwise. What about this dude? Is this guy consecutive with it also? Sure is. And you know how you can tell? Because look at these guys, these consecutive sides, maybe, they share an endpoint. Those consecutive sides share an endpoint. I got a green one highlighted and a red one highlighted. Where do they share an endpoint at? G, right? Isn't it segment GH and segment GM? Isn't G common to those? They share an endpoint. They are consecutive sides. So what would you call these guys, real quick? If I had this side and this side, are they consecutive? No? So what would you call them? Non-consecutive sides. You with me on that? You're either consecutive sides or non-consecutive sides. Then consecutive vertices. So again, they're right in a row. Let me pick this vertice. Isn't M a vertice? Give me one that's consecutive with it. L is one of them, and that's the other one? G, right? Got to be right in a row. You got to go around the clock, either clockwise or counterclockwise, right in a row. So consecutive vertices are endpoints of the same side. Endpoints of the same side are consecutive vertices. See this side that I highlighted right here? Segment ML. Isn't M and L the endpoints of it? Those are right in a row. They're consecutive vertices. If you wanted to say, well, what about M and G? Well, aren't they on the same side? Segment GM right there. There you go. Diagonal. Heard that word before? Diagonal. What's it mean to you? You go this way, right? Like you're thinking oblique is what you're thinking, probably. A diagonal and oblique are not even the same thing. A diagonal is this. It is a segment that connects non-consecutive vertices. It is a segment that connects non-consecutive vertices. It is a segment that connects non-consecutive vertices. Let's first pick on this guy. Let's draw a diagonal in there. Let's draw a diagonal from H. Where do you want it to go to? That'd be okay. Weren't those non-consecutive vertices? Is that the only diagonal I could have drawn from H, though? Where else could I have drawn to? M would be fine, right? Is there any other place I could have drawn a diagonal to? Okay. Those are diagonals. In my own words, I say it was 2 points that were not already connected, right? I can't draw anything else from H because I can either go to J, they were already connected, or to G, they were already connected. You with me? So I got a question for you. Is this dude, new color, a diagonal? Yes or no? Did I just connect 2 points that were not already connected? And you wanted to say no because that's going horizontally, correct? You're like, no, that's not a diagonal, that's horizontal. That's not the question. Diagonal does not mean oblique. It means, is it a segment that connects 2 vertices that were not already connected? Is this a diagonal? Yes, and it is going oblique, right? So it doesn't matter if it's horizontal, vertical, or oblique. Was it a segment that connected 2 points that were not already connected? How to name a polygon? Very easy. How to name a polygon? You name it by listing the vertices in consecutive order. You list the vertices in consecutive order to do that. In a row, right? In a row. So if I listed consecutive years, 2000, 2001, 2002, 2003, 2004, 2005, aren't those consecutive years, right, in a row? So pick a vertice, any vertice. Let's start with M, right? Let's name this dude. Start with M, and then let's go around the clock. It doesn't matter which way you go around the clock. You could go clockwise. Let's name them then. You go from M to where? G, H, J, K, L. Oops, how about an L? Do you see how I just listed those capital letters in order with no commas in between? What's the name of this guy? M, G, J, K, L, if I could read my own handwriting. Is that the only thing I could have called it? Nope. What if I started here and went around clockwise? What would it be called? H, J, K, L, M, G, correct? Could I go the other way around? Getting all messy here. Yes, I could go the other way. I could call it K, J, H, G, M, L if I wanted to. Now watch my pen. Could I call it L, H, G, K, J, M? Could I call it that? See how I jumped all over the place to do that? You got to go around the clock, either one way or the other. Who cares what you start with? If they were in alphabetical order, try to name them in alphabetical order, like this. What would you call that polygon right there? A, B, C, D, E, right? That would be the perfect name for this guy right there. All righty? So, convex polygon, and then we'll take a lunch break. Convex polygon. Here's what that means. You don't even have to write that down, okay? But it says, suppose the line containing each side is drawn. If any line goes through the interior of the polygon, that would be non-convex. So let me say that again. I'm going to draw a line that contains each side of the polygon. For example, boom. You see how I drew a line through that side right there? Did that line go through the interior of that polygon, yes or no? Nope, but I got to do that for all of them. Did that line go through the interior? Here's the rest of them. Did any of them go through the interior of that? That is considered to be convex. Put that on the inside of that word. That's a convex polygon. Because when I extended out all the sides of that dude, none of them went on the inside of it. You cool with that? What do you think about this guy right here? Will it be convex or non-convex? Well, check this guy out. See that? See how I extended that one side of it through? Did that line go through the interior? That is non-convex. And in my own words, I like to think of it like this. You see how this dude dents in, if you will? It kind of like has a dent in it. That means that that is non-convex. But if you can extend that out and your extension goes through the inside, non-convex. If you do them all and none of them go through, that's convex. Names of special polygons, specific polygons. Like, this is like how many sides they have. We're going to have names for special dudes. If it has 3 sides, 4 sides, 5 sides, etc., all the way up to 10 sides. Why can't you have a 2-sided polygon? There's one side, there's another side, can't be closed, correct? Can't have a one-sided polygon because that's just a segment, right? It's not a polygon in itself. So 3 is the minimum amount of sides. Please tell me you know what a 3-sided polygon is called. Boom. Let's not get that wrong. 3-sided polygon is a triangle. 4 sides. What do you think? Some people said square. Some people said rectangle. A square is a 4-sided polygon. A rectangle is a 4-sided polygon. But in general, they are all types of quadrilaterals. Right? There's many special types of quadrilaterals. Got to spell these words correctly also, by the way. And in Chapter 6, we will learn a ton about quadrilaterals, about what's a square, what's a rhombus, what's a this, what's a that, and etc. 5-sided polygon. Anybody know? In Washington, D.C., there's a building with 5 sides called the Pentagon. The Pentagon. Pentagon. Notice how it ends. Agon. It's pent-agon. How about a six-sided polygon? Anybody know? Hexagon. Now we're the brain tester. Seven-sided polygon. No español, por favor. Heptagon. Heptagon. Maybe back in your elementary days they called it a septagon. That's because little kids have trouble with two words that start with H. It's like a hexagon or a heptagon. It's like, well, let's just call it a septagon to make it sound different for you. But it's a heptagon. So how do you tell the difference between those two? Here's real easy. If you was to spell out this number 6, how do you spell the number 6? Does 6 have an X with it? Hex has an X with it also, right? 6 sides, hexagon. Please tell me you know what an 8-sided polygon is called. Octagon. It's not an octagon. That's the most misspelled of them all. They're all agons. Agon, 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 octagon. 9 sides. Easy way, because this one to me is the hardest. We kind of get pretty good with heptagon because it's very similar to hexagon. I say that you're non-gonna remember that one. 9 sides called nonagon. You're non-gonna remember that one. Nonagon. 9, non, 9, non, 9. 10 sides. You know, like a nice metric way to say 10? What's that? Deca, right? Deca means 10, so decagon. A decagon. And that's all we're going to learn. There are other names for special ones, like a 11-sided has a special name, 12-sided is a dodecagon, and 20 sides has a special name, 40 sides, 50 sides. They all have special names, but this is all we care about right now. So what would you call like a 13-sided polygon? Or what would you call like a 15-sided polygon? What would we call them? Well, after 10, we're going to say n is whatever number of sides they have, right? So if it was a 15-sided gon, wouldn't that have 15 sides with me? We call it an n-gon. Whatever n is, you'd call it an n-gon. So what would you call a 15-sided polygon, my friend? You wouldn't call it an n-gon, you would call it a 15-gon, and you do hyphen gon, right? What would you call a 30-sided polygon? 30-gon. What would you call a 3-sided polygon? Triangle. Don't pull into this 3-gon stuff. 5-sided polygon, 5-gon. You got a special name for these guys right here, correct? And the rest do not have special names, so we call them n-gons. Today's a weekend day, right? We'll have a weekend. Homework quiz next time. Got to know them. Got to know how to spell them right also. Cool? Got to know them. Next, draw a 4-sided figure that is not a polygon. See if you can get that done with PAL. Draw a 4-sided figure that is not a polygon. Need a geometer. Need a straight edge. There's many, many options. My simple one right here, 4-sided figure that's not a polygon. 1, 2, 3, 4. Got a 4-sided figure right there? And it's definitely not a polygon. What y'all drew, unless I told you specifically, those were fine. Draw a convex hexagon, A, B, C, D, E, F. So first of all, let's talk about this. Hexagon, how many sides? 6. Convex, in our own words, should it dent in or not dent in? So check out your geometer and find the wonderful hexagon on there. Is it convex in the first place? Which number is it on the geometer? 14. Might as well draw that dude, right? Use that geometer to your advantage. And then what's this A, B, C, D, E, F business all about? Those are the, what are those things called? The vertices. So I'll put them around there. What order should you go in? Well, does this one have to be A? Does this guy right here have to be A? No. I could have called it C if I wanted to, right? But what order did I put these in? Consecutive order. Cool. Over here, now we got to get really, really careful of how we read. Why don't you try number 3 with PAL and see what you got? Name the polygon by its number of sides. It says number of sides, right? So how many sides does it have? 5. And what do you call a 5-sided polygon? You were right. Just seeing if you can. All you got to do is justify yourself, right? You know, that's all I'm trying to get you to do. Name the polygon by its vertices. So what would you call it then? You'd use the vertices in consecutive order. And if they're so simple that's at the beginning of the alphabet, how about we call it A, B, C, D, E? I want you to notice something. How many letters are in A, B, C, D, E? 5. This was what kind of polygon? So you can tell how many sides a polygon has if they only give you the name by the number of letters that they give you. What if there was a 7-letter polygon? Wouldn't that be a heptagon, and etc.? So there you go. Is the polygon convex or non-convex? Non-convex. Because if I extended this dude out, doesn't it go straight through the interior of that bad boy? Name the sides of the polygon. I need some help. What are the sides of a polygon? So let's do this in a nice, neat order. I don't care what order you go in, but you should always try to have an order. Let's start maybe with this one. What would you call that one? Then go around the clock. You know, it's one way or the other. You know, like don't just jump all over the place. Have an order to what you're doing. Does it matter where the letters go? Could they be switched around? Segments are named by its endpoints. How many should you have when you're all said and done? 5. Then draw diagonal AC in the picture. You always use a straight edge. Draw diagonal segment AC in the picture. Like so. Have you heard the word equilateral before? So what does equa sound like to you? Equal. What does lateral mean to you? Have you ever heard of lateral movement? Like in a sport or something, you got lateral movement. Where would I move if I wanted lateral movement? Side to side. Lateral movement. What does lateral mean? Side. So what does equilateral mean? Equal sides. Boom. A polygon with all equal sides is equilateral. Equiangle means all angles are equal in a polygon. All angles have equal measures. Polygon with all equal angle measures. All equal angle measures. That's weird to say. All equal angle measures. Polygon. What do you think a regular polygon would be then? Any ideas? It's something that is equilateral and equiangular at the same time. So what does that mean if it's equilateral? All sides are the same and equiangular, so that's called regular. A polygon that is both equilateral and equiangular is a regular polygon. Regular. When you're describing these polygons here, they ask you to say convex or non-convex, and then if it's equilateral, equiangular, or regular, and by the number of sides. The word that should come first every time is either equilateral, equiangular, or regular. That's the first thing that we should describe. Okay, so let's look at this guy right here. Out of those three, is it any of those? Is it equilateral, equiangular, or regular? This is regular. All sides are the same due to the tick marks. All angles are the same due to the same amount of arc marks, right? So let's start with regular. Next word we need is what type of polygon this is by its sides. How many sides does this puppy have? How many? Sometimes we get a little confused, so I do this. I just kind of put a mark on one to realize where I started, so I can go around and be like 1, 2, 3, 4, 5, 6. You know, there are 6 of them, so I don't count the same one twice. So 6 sides, what we call that? Hexagon. So you wouldn't say hexagon regular. You always call it a regular hexagon. That's why we started with that word. Then they said, is it convex or non-convex? What do you think? Convex. It is impossible to have a regular polygon that is non-convex. It can't happen because the angles wouldn't end up being the same if it was non-convex. And you look at this. Isn't this guy non-convex? What's that angle measure? It's more than 180 degrees because the angle you have to measure is right here, and that's not even on the inside of that polygon in the first place. So not possible to have a regular non-convex shape. Next guy. Regular Equilateral or equiangular? Equilateral. Equilateral. Number of sides? 4. So what's that called? It's a quadrilateral. Quadrilateral. There's an I in the middle. Quadrilateral. So that's an equilateral quadrilateral, which is awesome to say. Is it regular, or excuse me, convex or non-convex? Convex. Finish these bad boys up. Is that all? No. Types of triangles by side. You can also call triangles by their angles. Do you know what kind of triangles you have by angles? Acute triangle, right triangle, and obtuse triangle. That's not what we're talking about. We're talking about their sides. Equilateral triangle. What would that mean if a triangle is equilateral? And how many sides are there? So here's its definition real quick. It has 3 equal sides. Put it real small underneath there. Then we'll draw one. We will draw one with our geometer. What shape is the equilateral triangle on the geometer? Dead center, baby. 13. Dead center of your geometer. Shape 13. So we draw this. Is that an equilateral triangle? Not one bit. It looks like they're all the same length. Doesn't matter what it looks like. What do you need? Gotta have them. All the same. Booyah, booyah, booyah. That is an equilateral triangle. Isosceles triangle, the hardest word to spell. Isosceles. Gotta spell it right. Anybody got a guess what an isosceles triangle is? Go for your guess. Wrong! That's what you've been taught in the past, which is wrong. People always say it's got 2 equal sides. There are 2 magic words in the isosceles triangle. It has at least 2 equal sides. That's where we start getting confused. An isosceles triangle has at least 2 equal sides. So before we even draw one, see this guy right here? Is it isosceles? Yes, it is also equilateral. It's like, interesting. We'll also learn some crazy stuff like, I'll bet you know what this shape is. What's that? That is a square, right? To be a square, you must be a quadrilateral with 4 right angles and 4 equal sides. Have you ever seen this shape before? Rectangle. To be a rectangle, here's what you need. You need 4 right angles, right? Question for you. Does this have 4 right angles? Is it a rectangle? To be a rectangle, all you need is 4 right angles. Does this have 4 right angles? Is it a rectangle? And it's very simple if you think about it like this. Must be 18 to enter a certain place, right? Got this place, must be 18 to enter. I'm 34. Can I enter? Yep, but I sure as heck aren't 18. I'm not 18. I'm 34. But don't I meet the requirements? Because they should say must be 18 or older to get in. Must have 4 right angles to be a rectangle. Does this have 4 right angles? It's a rectangle, but it's also more than that. With me? Does this have at least 2 equal sides? It's isosceles, but it's more than that. So to draw an isosceles triangle, it is shape number 1 on our geometer. If they ever tell you to draw an isosceles triangle, please use shape number 1 and only put 2 sides the same. So we will do this. Boom, boom, tick mark wise. I want to show you something that people do that's not correct. They do this. Can't do that because you don't know that. You don't know that this side is different than those because it could come a day where we might prove that this side is the same as these others. All we know is it's supposed to be isosceles, so it's got to have at least 2 equal sides. But we don't know if this side's the same or not the same. Are you with me on that? So only mark that. And then scalene. That's an interesting word. Scalene. What do you think? If this got at least 3 equal sides, this has 3 equal sides, this has at least 2 equal sides, what would this have? No equal sides. Has no equal sides. I like shape number 2 for that personally. You can use a bunch of them. You can use the smaller one if you wanted to also, but I like shape number 2. Does that have no equal sides the way I have drawn it? Are you sure? We don't know for sure. There's only one way to know for sure that all three of those are different. We need tick marks. So if I put one tick mark on this guy, then what do we got to do on maybe this guy? 2. And then what about this guy? All different amounts of tick marks means for sure that they're the same. Without the markings, they could be, they might not be. We don't know. Cool? That's all that we got.